Hello info person, this is Anton, and in this video we're going to be discussing one of the most persistent mysteries in astronomy. The case of missing antimatter. But more specifically, we're going to discuss a much more recent and strange discovery that suggests that antimatter is not just missing, it's actually physically escaping our galaxy and behaving in ways that our current laws cannot explain. In other words, we have a new mysterious discovery coming from the Milky Way galaxy that once again shocked a lot of astronomers. But before we start, just so that we're all on the same page, what exactly is antimatter anyway? So let's do a quick refresher. And here's actually a really cool image taken back in 1932. First ever image that physically confirmed antimatter is real. This is a track from a positron inside a cloud chamber. In this case, a positron is of course the antimatter of an electron. And while most of the stuff we see around us, stars, planets, and even people, are made out of ordinary matter. But for every particle of matter in existence, there can technically be an antiparticle. So once again, for the electron, this would be a positron. It essentially has exactly the same mass and exactly the same spin as an electron, but it carries a positive charge instead of a negative charge. And the strangest thing about these two particles would be that if they were to meet each other, they would actually annihilate, producing a tremendous amount of energy. They basically vanish in a tiny explosion, turning all of their mass into pure energy in the form of gamma rays. And in this case, gamma rays with very specific energy signature. Here, this type of a positron annihilation is always 500 kilo-electron volts. Something that has been measured in a lab many times. And the thing is, if we were to find these gamma rays of that specific energy in outer space, we could conclude that what we're actually seeing is basically the glow formed by antimatter annihilation, which is precisely how astronomers usually map antimatter in outer space. By seeing it destroyed, we know it's there. And just as a side note before we continue, in 2026 there was actually first ever achievement of something that has never been done in physics, specifically antimatter delivery. And so in March of 2026, for the first time in history, researchers found a way to move antimatter from one location to another, which is a big deal because, as I just mentioned, when antimatter touches regular matter, it annihilates, creating a tiny explosion. But researchers at CERN have now developed a technique that allows them to transport quite a lot of antimatter all at once. Which is really important for physics because normally it's extremely difficult to produce this and only particle accelerators can create this on Earth. And so up until this point, it was only possible to study antimatter on location. In this case, for example, CERN in Switzerland. But by making this happen, it can now be transported to other labs on the planet and can thus be studied in other physics labs through this process of antimatter delivery. And so I guess if you're a physicist somewhere out there, you're going to be able to find this on Amazon sometimes in the future. Okay, just kidding. I don't think it's going to qualify for Amazon delivery. But this was still a pretty cool achievement. Because now antimatter is not just a sci-fi concept, it's something that we can physically measure, create in a lab, and thus possibly use for some kind of a future technology. But despite of this, there's still this persistent mystery. Why exactly do we find so little of it in the universe? And why is it so difficult to find in outer space? Because theoretically, at least according to modern physics, once the universe was created in the Big Bang, it should have created an equal amount of matter and antimatter. And the thing is, if that were true, they should have actually annihilated each other already, leaving the universe with nothing but energy inside. But obviously we know that that didn't happen, because here you are, material and all, watching this video. In other words, we live in a universe dominated by regular matter. And so something in the early universe must have favored matter over antimatter, allowing more to be produced. Today this is technically known as the CP violation. It's a physics term you can learn about in one of the previous videos in the description. And that suggests that matter and antimatter don't always behave like perfect mirror images of each other. But exactly why, we don't really know. And today scientists are trying to understand this by studying various exotic atoms, such as what's known as Positronium. And here positronium consists of just one electron and one positron orbiting each other. It's essentially the lightest known particle system, but it's also obviously extremely unstable. Usually this annihilates in approximately 144th billionth of a second. And so because it moves so fast and because it disappears pretty quickly, it's extremely challenging to study this. Although in some of the recent experiments at CERN and University of Tokyo, researchers realized that they can actually slow down positronium by using specific lasers and by basically cooling it down to almost absolute zero. At that point, it survives long enough where it can now be studied. This is actually a recent achievement, but nothing has been learned about it just yet. Either way though, the existence of positronium is obviously kind of cool, because it's basically a kind of a superparticle, or a particle made out of matter and antimatter, which scientists are now hoping might lead to creation of some kind of a coherent gamma-ray laser, which one day might even allow us to scan atomic nuclei and essentially be able to create microscopes with incredibly high resolution. But that's obviously just theoretical for now. Because the biggest mystery is of course this very recent discovery in regards to escaping antimatter from the galaxy. Something that was recently discovered in the new data from the Integral Space Telescope. The telescope, whose main purpose so far has been to detect these 511 kV emissions and to basically map antimatter in the night skies. And for a very long time we've known that there's a lot of antimatter in the center of the Milky Way. As a matter of fact, this is the combined image showing us what seems to be happening here, with the center itself containing the most. But for some reason there's still way more than should be possible. As in, the center of the Milky Way contains sources that are difficult to explain. And though normally we expect things like black holes and pulsars to produce some of this, in this case we don't expect to have so many black holes and so many pulsars, suggesting that these emissions are just a little bit anomalous. And so the new analysis from 20 years of Integral managed to find something even stranger. There seem to be these very unusual extragalactic hotspots of antimatter annihilation, with many signals appearing far above and far below the disk of the galaxy, in regions like Complex C, which represents a massive hydrogen cloud, and the Magellanic Stream, or this really long trail of gas left behind by the Large Magellanic Cloud and Small Magellanic Cloud interacting with each other and the Milky Way. And well, this is strange for two reasons. First, the speed of positrons. In order for them to annihilate with electrons, they actually have to move pretty slow, because otherwise they're not going to be producing these 511 kiloelectron-volt signals. And that means that whatever antimatter is here has to be moving pretty slow and must have not come from the center of the galaxy or anywhere far away. Second, the distance here is pretty huge, and so if they're slow, they shouldn't have enough energy to escape the Milky Way's disk and reach these far-off gas clouds before they hit something and annihilate. Yet somehow they are still here, and that implies that they're basically being produced by something. Or essentially this suggests that a large number of high-energy positrons are actively being produced in the Milky Way and are then leaking out into the surrounding space. And if this is true, the Milky Way might be producing 100 trillion positrons every single second, which is basically 1 followed by 44 zeros, and is also at least 3 times higher than previously assumed. But the obvious question is, where is it coming from and what's producing this? And that's because if conventional sources like stellar explosions, neutron stars and black holes can't account for this many positrons, we might have a bit of a problem. Because once again there seems to be 3 times more antimatter than previously predicted, with physicists now considering more unconventional ideas, such as maybe this is some kind of a dark matter. Basically light dark matter particles that are actually annihilating to produce antimatter. Although in this case, this would be very difficult to prove right now. Alternatively, maybe this is the result of neutrinos, or these tiny, nearly massless particles that are passing through right now many times, with some theories suggesting that neutrinos could be their own antiparticles, and in this case, a neutrino can basically turn into antineutrino and eventually annihilate, producing these emissions. But the point is that right now nobody actually knows what's going on, and the only thing that's certain is that there are definitely a lot more local antimatter sources than we ever predicted. And so what exactly are some of the implications from this, and what kind of a conclusion can we come to? Well, right now it's pretty obvious that nothing in the standard model of physics can currently explain this, which basically suggests that there is maybe either new physics going on here, or there are some forces and particles that we just don't understand yet. Or maybe this is actually dark matter after all, and we might have our first clue in regards to its existence, and thus, by using these emissions, can establish what it's made out of. But at the same time, we also know that this is not a uniquely Milky Way thing, because slightly weaker hotspots have also been found in nearby clusters and galaxies, such as Andromeda, Triangulum, and the Virgo cluster, which basically confirms that this positron production seems to be some kind of a universal galaxy-scale phenomena, and thus involves a new phenomenon. But luckily, in 2027, we are going to have a new telescope, specifically COSI or Compton Spectrometer and Imager, that's going to be much more sensitive than previous observatories and should be able to confirm these findings, or maybe even discover something else. But if these findings are correct, we're going to have to rewrite our understanding in how galaxies produce and lose their antimatter. For now though, we definitely have these unusual hints that the universe seems to do things a little bit different from how we imagine it to do. And so either the Milky Way is producing way more antimatter that's then essentially escaping to the outskirts and annihilating there, or we have our first hints of dark matter annihilation, or maybe this involves some kind of new physics and something we cannot explain just yet. So just as a very important side note, right now these findings only have a statistical significance of 4 sigma. But in physics, normally, in order to have a definitive discovery, we have to have 5 sigma. In other words, additional observations and additional data will hopefully tell us what's going on. On that note, once we discover something else, we'll come back and talk about this in some of the future videos. Until then, check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon, where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.